Welcome everyone to this explainer. Today we're jumping right into what I can really only describe as an elite mathematical masterclass based on our source material. We are going to unpack an absolutely mind-bending framework known as Logos field theory and the Adelic Langlands program. Together, we'll discover how a fundamental rule of computer science might not just be some quirky programming artifact, but the absolute mathematical law that dictates the stability of the physical universe itself.
Okay, let's dive into this syllabus. We're going to build this step by step. We'll start with the universe's hardware limit, move into mathematical crashes and confinement, explore tensors in anisotropic space, unpack the balancing law, do the math of time dilation, and finally wrap up by calculating dispersion errors.
All right, part 1, the universe's hardware limit. Let's get right to the foundation of our derivation.
To really understand our universe as a literal computational framework, we have to talk about the Courant, Friedrichs, Lewy, or just CFL condition. Think about classical computer science for a second. When engineers simulate complex partial differential equations, this condition is basically a convergence limit. If you violate it, meaning if your Courant number, C, goes above 1, boom, syntax error, your simulation just crashes on the screen. But in the Adelic Langlands program and Logos field theory, we're not talking about a code artifact on a laptop anymore. This is an absolute vacuum stability selection rule. Violating the CFL condition here doesn't crash a screen. It means physical space itself undergoes a massive algorithmic collapse. Wild, right?
So let's actually look at the math of this semi-classical shadow. The Courant number, C, has to be less than or equal to the absolute stability threshold of 1. You calculate this by taking v, your wave propagation speed, multiplying it by the discrete arithmetic time step, delta t, in the numerator, and then dividing that whole thing by the spatial pixel, delta x, in the denominator. And in this arithmetic universe, that delta x isn't just some arbitrary grid size. It maps directly to the regularized core radius, which is derived using the Airkolov-Green's function for a specific prime loop.
Moving on to part 2, mathematical crashes and confinement.
So, what actually happens when physical data tries to break this unbreakable mathematical limit? Well, imagine a scattering state desperately trying to escape a ramified prime coordinate. If its local velocity spikes and actually breaches the baseline speed of light in a symmetric grid, where delta x is roughly equal to delta t, the equation suddenly spits out a Courant number greater than 1. Essentially, information is trying to move way faster than the underlying Adelic data stream can even process it. The result? You get an immediate, catastrophic algebraic crash.
To put a precise number on it, the calculated escape velocity for this exact state is about 1.604 c. And because that velocity is strictly greater than c, our baseline speed of light, it triggers that massive mathematical instability. The underlying data stream literally just cannot execute the movement. It's a hard hardware limit.
Because of this, the universe has to execute a step-by-step error correction protocol to save itself. Step 1, that local velocity spikes above c. Step 2, the CFL evaluation instantly breaches unity. Step 3, an algebraic crash is triggered. And then, Step 4, to restore absolute stability, the vacuum steps in and explicitly prohibits this unstable data from propagating. It physically forces the data stream to collapse, completely trapping the scattering state inside a black hole-style prime core. It is total arithmetic confinement.
And you know, this very protocol actually dictates the size of our visible universe. The universe generates an absolute cosmological horizon distance locked in at exactly 3.265 times 10 to the negative 35 meters. That's the Planck scale. Why there? Because the accelerating expansion rate of space acts as this hard algorithmic information screen. It's perfectly tuned to ensure that the maximum physical domain of dependence never outpaces the processing capacity of the underlying Fourier-Mukai kernel. The math is essentially telling us the visible universe is restricted in size strictly because the absolute Adel ring simply refuses to run a crashing simulation.
Which brings us to part 3, tensors in anisotropic space. Now we're going to crank up the complexity a bit, moving from a simple scalar equation to the rank 2 matrix tensors required for an anisotropic background. When we introduce an antisymmetric arithmetic flex into the mix, the isotropic gravitational constant actually bifurcates. Spacetime itself becomes anisotropic, meaning wave propagation speeds become highly directional. Looking at the rank 2 velocity tensor, Vij, the antisymmetric flux literally forces the velocity to split. You get a parallel profile which decreases by a factor of 1 plus theta squared to the negative 1/4, and a perpendicular profile which increases relative to that non-commutative theta flux.
Now, what's really interesting about this slide is how the spatial grid actually adapts to all of this. Because the anisotropic metric is warping local space, those spatial grid steps, our delta x components, well, they aren't uniform anymore. In the covariant grid matrix, they actually warp to perfectly match the directional pixel sizes of the underlying data stream. The parallel spatial steps actively squeeze down, while the perpendicular spatial steps stretch out.
And here is where the math gets absolutely beautiful. Let's look at the Courant tensor identity. We formally upgrade to a mixed rank 2 Courant tensor by merging our directional velocity tensor with those inverted covariant grid matrices. When we substitute the directional velocity components and those warped spatial step parameters back into this tensor, look at the final result. The non-commutative theta flux terms completely cancel each other out, perfectly. The entire matrix elegantly reduces right back down to a completely isotropic, perfect scalar multiplicity.
All right, part 4, the balancing law.
Let's actually pause the derivations for just a second to internalize the physical meaning of that perfect mathematical cancellation we just calculated. We call this the dynamic balancing law. See, while the non-symmetric period matrix is warping both the physical velocity of light and the actual size of the spatial pixels, it's doing so in exact structural lockstep. If it didn't do this, specific spatial axes would inevitably breach the stability limit way before others, and that would cause directional algebraic crashes left and right. But this exact mathematical cancellation proves that the absolute Adel ring actively preserves universal computational stability. It completely neutralizes any chance of anisotropic vacuum decay.
Next up, part 5, the math of time dilation.
So how does this hyper-adaptive grid respond to intense dynamic events? And this brilliantly illustrates the crisis of a wall-crossing phase transition. On the left side of the breakdown, as the system crosses a wall of marginal stability, bound states begin to decay. This triggers a sudden, abrupt step function drop in the fiber volume. This massive volumetric contraction forcefully shrinks the spatial pixels and intensely scales up the wave velocity. Now look at the right side. This is the real threat. If the internal clock rate somehow remains static through this, it would trigger a massive exponential surge in the unadjusted Courant number, basically threatening a superluminal grid breakdown.
To absolutely prevent this catastrophic crash, the system enforces a strict global invariance using the clock reshuffling equation. To perfectly balance out those compressed pixels and the intensified velocity we just talked about, the post-crossing time translation interval, delta t, has to instantaneously drop. You can see right here it scales down by the exact warp parameter, xp minus delta beta. Now, to a macroscopic observer like us, this instantaneous clock reindexing behaves exactly like relativistic gravitational time dilation. The universal clock literally slows down for no other reason than to block a CFL violation.
Finally, we arrive at part 6, calculating dispersion errors.
For our final calculation today, we're going to evaluate the exact numerical error propagation for a gluon traveling through this discrete pixelated grid. Because space is basically an A2 hexagonal grid mapped by prime loops, not a perfect, smooth continuum, it inherently acts as a dispersive medium. When we deconstruct the Taylor expansion of the discrete hexagonal dispersion relation, we can perfectly isolate the leading order group velocity dispersion error. Basically, at extreme high energies, the phase velocity and the group velocity completely unsynchronize.
If we calculate this out for a grand unified theory scale gluon packet, let's say 10 to the 15th GeV, traveling over a really tiny but technically macroscopic distance of just 10 to the negative 15 meters, the absolute dispersion phase error is incredibly massive. It calculates out exactly to 2.13715 times 10 to the 6th radians.
And that massive phase blur acts just like ultraviolet chromatic aberration. The high-energy gluons severely lag behind the lower-energy ones. As they scramble over these macroscopic distances, they get hit asymmetrically by directional errors, which physically forces topological color splitting. The supposedly unified SU3 gauge symmetry actually fractures into entirely decoupled red, green, and blue component streams, meaning the smooth, continuous spacetime we think we observe is ultimately revealed to be nothing but a low-energy illusion.
We've seen today how the speed of light, gravitational horizons, and even time dilation all mathematically emerge just to keep the absolute Adel ring from completely dissolving into algebraic noise. Which leaves us with the truly staggering question to ponder. If the smooth physical laws we observe every day are really just low-energy illusions hiding a highly adaptive pixelated computer, what other unbreakable rules of our universe are actually just algorithmic error correction protocols?